This is problem number 9 from section 3.2. In this problem it says a company charges $20 to make one monogram shirt, but reduces this cost by 10 cents per shirt for each additional shirt ordered up to 100 shirts. If the cost of an order is $917, how many shirts were ordered? This problem's a good problem because it's kind of a mind twister when it comes to this last part of this sentence. It says, but reduces this cost by 10 cents per shirt for each additional shirt ordered up to 100 shirts. There's a lot going on in the problem. The first thing we need to do is just to declare, and I've done that here, that the thing we're looking for is the number of shirts. So X is the number of shirts. Now, they say one shirt is $20. So if you just buy one, it's 20. But if you buy two, it's going to be, so let's kind of write this out. This is 20. If you buy one, it's just 20 times 1, which is $20, right? If you buy two, though, you're going to end up paying $19.90 times 2. If you buy three, you're going to pay $19.80 times 3. Then $19.70 for 4. Then $19.60 for 5. So on and so forth. So that's the pattern that they're talking about taking 10 cents off for every shirt that you order. Now we've got to come up with a way to basically subtract out 10 cents every time, but we can't subtract out 10 cents right away. So let's start with the $20. We're going to say that, well, let's make a function here. We'll say that the cost, we'll say that C of X is going to equal $20. $20, and it's $20. We need to subtract out 10 cents. But do we subtract out 10 cents for the first shirt? Because if I put X right here and I put a 1 in that in for that variable, that's now $19.90. I don't really want to do that. I don't want to actually start to subtract out until I get to the second shirt, right? So we're going to say here in parentheses that this would be the first, or the number of shirts minus 1, because the first shirt I'm going to ignore. That way when I plug a 1 in here, 1 minus 1 is 0. Take it times this and it cancels it, leaving you just with 20 bucks. But when I put a 2 in there, 2 minus 1 is 1. Now I'm going to subtract out the 10 cents for the second shirt. But all of this has to be multiplied by the number of shirts, right? This is just getting you the cost, right? 20 minus 0.10, let's say that were 2, it'd be $19.90, right? This will give you $19.90. I actually have to take it times the number of shirts. So I'm going to put parentheses around this and multiply it times X, which is the number of shirts. This is where this was a kind of a mind twist. It's $20 minus the 10 cents for X minus 1 shirts, meaning just after the first shirt, you're going to actually start to subtract 10 cents, right? So when you put a 1 in here, it cancels it out. When you put a 2, now I'm subtracting 10 cents. Put a 3, now I'm subtracting 20 cents, so on and so forth. But I have to multiply that by the number of shirts as well. So it's kind of a lot going on there. Now they tell us the cost is $9.17, so I'm actually going to set this equation, $9.17 equal to 20, and I'll start to distribute here to kind of solve. This is $20 minus 0.10x plus 0.10 times x. Remember, we're trying to find x. Let's combine stuff on the inside. So it's 917 equals 20.1 minus, when we combine the 0.1 and the 20, that's how we got 20.1, minus 0.10x times x. Distribute, we get 917 equals 20.1x minus 0.10x squared. Now we're going to get this quadratic equal to 0. So I'm going to add this 0.10 over. to each side. And that's now 0.10x squared plus 917 equals 20.1x. And now I'm going to subtract that over. And that's 0.10x squared minus 20.1x plus 917 equals 0. So now we have a quadratic that we can solve. The hard part about the problem was right here. This is the hard part. After that, this is just algebra that you've done. And so at this point, you can see we're probably going to use the quadratic formula. So I'm going to go ahead and write that up there, the quadratic formula, and put that right there. So x is going to equal negative 20.1, because that's b, right? Plus and minus negative 20.1 squared, and this should be a root, my bad, minus 4 times a, which is 0.1, times c, which is 917. Okay, and that's all over 2 times a, which is 0.1. So x equals, and we're going to use a calculator to do most of this, so it's 20.1 here, plus and minus. Let's go ahead and use our calculator to plug all that in. Save ourselves lots of headache there. So I'm going to say negative 20.1. I'm just going to put in exactly how it's written there. Negative 20.1 squared minus 4.1 times 0.1 times 917. 37.21. Now I'm going to do the square root of that, right? Because we got to do the square root. 6.1. So when I do the square root of all that, I get 6.1 here. That's over 0.2. So this is going to equal 20.1 plus 6.1 over 0.2, or 20.1 minus, I'll write that better, 20.1 minus 6.1 over 0.2. So what does x equal? Well, x could equal 20.1 plus 6.1 divided by 0.2, 131. Meaning the number of shirts could be 131. Or x can equal 20.1 minus 6.1 divided by 0.2. 70. So I got two options. Either I was 131 shirts or 70 shirts. But at the very beginning they said ordered up to 100 shirts. So that means that will not work. The only solution is 70 shirts. I hope that makes sense. That's the most difficult part. Just continue to reread that and just think through it. If anything, what I would do is take this and start plugging in x values and writing out what the numbers are. That might help as well.